Alright, so we're talking about limits here. Now, there is a long and complicated description right here. Ignore it. Don't worry about that. Okay? Because this is the official definition. So, I'm going to read it out for you once, but then once I've read it out for you, you can ignore it because the bottom one tells you what it is. So what a limit is it tells you what happens when you're close to that value. So let's say you want to find here x going towards a value of a. So for example, if it's a 2 or if it's a 3, and you have a graph that kind of looks like this, and then it stops at 2, and then it does something else. That's why you need the limits, because you can't technically find a point at 2, but you can evaluate what happens when you're up to it. Sorry, wrong dot. It should be an open dot, like that. Now, all of that description is quite long and complicated, but you just want to know what happens to that dot, right? So let's say you can see the dot there. Do you think you can say what kind of value it is?
24.
Like if I told you that this dot is 2, 4, can you tell me what the dot is at that point in terms of y value? You can, right? Because it's already labeled there as 4. Yeah? So this means the first point here. If a function is well behaved, which means you can find the point where it doesn't go to infinity, then substitute x equals to a. So for example, if you had to find something like the limit as x goes towards 1 for a really simple function, x plus 2, you would just substitute 1 in, so 1 plus 2 giving you a 3. Fairly simple, you're just substituting. Now, if there's something where it's not well behaved, which means you're going to be dividing it by something else, then you'll have to actually do some substitutions to make it work. I'll show you what that is when I get up to one of the examples. And then the last one is, if it's not possible to obtain a well-behaved function, then the limit does not exist. So, if you're not entirely sure what it is, in terms of well-behaved, you will see in 1 second. Alright, calculate the limits wherever possible. So, see how this is x going towards 2? If you sub in 2, nothing bad happens, so you can just simply put in 2, which is 11. Hooray! Very difficult, isn't it? Now, here's a tricky one. See part B. If I sub in part B with -1, note what happens on the bottom. If I put -1 in, that gives us a 0, which is undefined. So we can't do that. But instead, we're going to do something else. Instead, we're going to actually do a little bit of manipulation in order for us to work this out. See how that's x squared minus 1? What does that factorize to?
1.
Yep, x plus 1. And then on the bottom you have x plus 1. Now when you divide the two, notice that that disappears. So now you're left with the limit of x going towards -1. Can we just substitute it in now?
Yes.
Yep, so substitute it in, giving us a -2. Now all this means is the point is going towards -2. It doesn't mean it actually will. But in terms of us working it out, that's what happens. And so that's what that means. Alright, C is a little bit more annoying. So we have done something like this before. Alright, C. C, you have no way of manipulating it, right? There's nothing for you to divide on the top that can actually help us. So you just simply write down that it's undefined. Simple enough?